Linear versus exponential by Carlee and Julie. The narwhal species currently populates Alaska. Prior to 2001, the population was 200,000. However, due to hunters, the narwhal species has been declining by 20% over the years. How many narwhals will there be in 22 years? How long will it take until the population is less than one-half the original population? The recursive equation for this problem is next equals now times 0.8 start equals 200,000. The start comes from the population in 2001 being 200,000, and the 0.80 comes from the decline of 20%. So you have to multiply it by 0.80 because 80% of the population is left. The explicit equation is y equals 200,000 times 0.80 to the x power. 200,000 is the initial population value. 0.80 is the number of which the population grows or stays the same each year, and x is the time since 2001. On the graph, the year since 2001 is the x, so 0, 1, 2, 3, 4, 5, and then y is the narwhal population in thousands. So 60, 70, 80, 90, all the way up to 210,000. And then the graph is year since 2001 is 0. The narwhal population then was 200,000. The year since 2001 was 1. The narwhal population since then was 160,000, and so on. The solutions to solve the questions of how many narwhals will there be in 2 years was y equals 200,000 times 0.80 to the second power because x equals the time and 2 years is the time frame. So y would then equal 128,000. The solution to question 2, how long will it take until the population is less than one-half the original population, is 100,000 is half of 200,000, so that's the y value that you're trying to find. But since you can't, there's no real way to solve this without, you have to guess and check. So y equal 200,000 times 0.80 to the third power is how many narwhals there will be in 3 years, which is 102,400. But since that's up higher than half 100,000, you have to continue guessing and checking. So you go y equals 200,000 times 0.80 to the fourth power, which is equal to y equals 81 times 920,000. Since that is less than 100,000, that's the answer. So 100,000 is equal to 200,000 times 0.8 to the x. X is between 3 and 4 years. For the linear growth equation, I chose to do Cassidy School is having a school fundraiser. For every lap she runs, her mom will donate $20. After her initial donation of $10, how much money will Cassidy earn on her 5th lap? How many laps will she have to run to earn $150? Recursive equation for this problem is next equals now plus 20 because she earns $20 each lap. The start is 10 because her mom donates $10 when she hasn't run any laps. The explicit equation is y equals 20x plus 10 because 20 is how many laps she runs, so it's the slope, and x is we don't know how many laps she's run, so that will be any laps, the number of laps she runs later, plus 10 because that's the initial amount. The graph shows x being the x-axis being the number of laps run and y being the amount of money earned. So it increases by 10 and x increases by 1. So here you can see the linear line going up, increasing by 20 each time. And then the table shows this in complete. So 0 equals 10 because she hasn't run any laps, so her mom donated $10 before. And then 1 would equal 30 because of the equation of y equals 20x plus 10, and you would plug 1 into x, so 20 times 1 plus 10 equals 30, and so on. The solutions for question 1 is how much will Cassidy earn on her 5th lap? So y equals 20x plus 10 is your original equation, so you plug 5 into x for the number of laps she's run. So y equals 20 times 5 plus 10, which then equals 110. The answer to the second question is how many laps will she have to run to earn $150. For this, you have to solve and do guess and check. So y equals 20 times 6 plus 10 equals 130, which is too low. So then you move on to, you try and plug in another value. So y equals 20 times 7 plus 10 equals 150. So 150 equals 20x plus 10. So x equals 7 laps because it then equals $150, the amount she needs to race.